Well, hey everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host as always, and I want to thank you for taking the time to watch this video where we're going to learn a little more about residential wiring. And of course, as always, we're going to be utilizing our residential wiring program that is available over at the Electricians Academy. So if you would like to get a real in-depth understanding of residential wiring, room by room, all the little nuances, circuit design, why we're doing it, and a lot of tips along the way to enhance your knowledge of residential wiring, but maybe you're a company and you want to get all of your residential electricians on the same technical page. That's what you'd use this program for. Again, so residential wiring is, of course, it's available at the Electricians Academy at electricalinstructor.com. But you also have commercial, industrial, grounding and bonding, and electricity 101, all available there as well. And they are all very in-depth, just like this residential program. There's a lot of units in this program. And so you might have watched a previous episode where we talked about maybe the basics of the bathroom circuits and lighting and receptacle. And again, we kept it very light, not too code laden, kind of keep it easy to understand. That's an effort with this type of series. But the programs really do go into code as well. So it kind of hammers home the code requirements as well. And there's links that you click in order to be able to understand some areas and jump to other areas in the textbook. And you'll see that as well in today's episode, because today's episode, we're going to talk about the master bedroom. And we're going to kind of give you some thoughts and concepts and things you may do, you may not do, and things like that when it comes to bedrooms, master bedrooms. Okay, so without further ado, let's go on and jump into that. And again, all of this is based on our residential program that is available over at the Electricians Academy at electricalinstructor.com. Okay, so introduction. We're going to talk about master bedrooms and kind of, there's a lot of little things that go along with that, and we'll kind of touch on them. But this is kind of an example of what the course is like, but I really wanted to touch on some of the key components. Now, since we're talking about master bedrooms, let's read it. First off, the introduction. It says, the discussion in Chapter 3 and Chapter 8 about grouping outlets, estimated loads, selecting wall size boxes, that's box fill and all that kind of stuff, and wiring diagrams will be very helpful when you're laying out a master bedroom. Now, we're not going to go into those chapters, but just so you know, in the residential program, people say, what does that program really have? It literally walks you through everything in designing the loads, understanding the grouping of outlets, how you might route things, and all of those things are covered in this program. So this is an extensive program, and we test you on all that to make sure that you truly do understand the aspects of it. And I look like a hillbilly now with that there. There we go. So again, make sure if you get our program that you go unit by unit by unit or chapter by chapter, and you're really going to get a lot out of it. But today we're going to talk about master bedroom. Now, for our example, it says the residence panel board schedule show that the master bedroom in our circuit layout, and you'll see that in a second, is supplied by circuit A19. So in our panel, A19 is the circuit, the branch circuit that's going to be supplying power to our master bedroom. Now, it's a 15 amp branch circuit. Some people ask, can I do that on the 20? Absolutely. But again, not required to do anything greater than a 15 amp. Okay. So we're using a 15 amp for this application. Now, if you're familiar with the National Electrical Code, you know that there's an arc fault circuit requirement. So 210.12a tells you, obviously, the bedroom is the branch circuit that supplies the outlets and devices and things like that inside of the bedroom has to be AFCI protected. Now, this is the branch circuit itself. The complete branch circuit has to be protected by AFCI. Now, 210.12a does give you some options, okay? You could put a breaker in the panel that's at AFCI, and you could have that protect the whole circuit, but it does give you some allowances to put an outlet-style AFCI device at the first receptacle of the branch circuit. Again, you do have options, but you need to look at 210.12a to understand all those options. Now, also what you're going to have is an overcurrent protected device. In our case, it's a 15 amp. But because the bedroom does fall under the requirements in 210.12a to have AFCI protection on that branch circuit, then we're also going to have an AFCI breaker in the panel. That's how we're going to do it in our installation. So it's a 15 amp overcurrent protected device that is also an AFCI device as well. Okay. Now, if you, in our program, there is a chapter 8 as well that talks about GFCIs and AFCIs and how you might achieve both in a room that required both AFCI and GFCI requirements. Okay, so you do have a lot of extra detail in chapter 8 that talks about it. And of course, if you watched my bathroom residential video, I explained the difference between AFCI combination and then what's called an AFCI GFCI dual function. Now, I hate to get repetitive, but that is the nature of how I teach. So an AFCI combination is looking for two types of arcs. That is both parallel and series arcs. Series being, let's say, conductor at a termination where it's a poor termination. It's very load dependent, so you have no current traveling through if there's not a load. And so if it's sitting at a terminal and it's not torqued right, and a load all of a sudden comes on the circuit, then you could have an arc take place. So that is an example of a series arc. You could have a piece of wire that is cut or damaged in close proximity, and when the load is being drawn on the circuit, it creates an arc across it. And over time, that arc will generate heat, and that could be a significant issue to start a fire. Now, when it comes to a parallel arc, those are arcs that are parallel between mutual conductors. For example, you have a black and a white and an NMB, and there's an arc between those two. But it could be an extension cord that gets damaged in a doorway, and you have an arc that's taking place between the hot and the neutral, for example. That is not load dependent, okay? That is a direct arc between the two conductors, and it might not be enough to be a short, but it is enough to create an arc, and that is called a parallel arc, okay? So an AFCI that's combination type is looking for both parallel and series arc, and I'm trying to keep it as basic as I can. Now, a dual function AFCI is also performing a GFCI function as well, and that is personal safety. That's a 5 milliamp nominal type of GFCI protection, Class A device. Now, that dual function can handle both. So if you have an area which requires both AFCI protection and GFCI protection, a good example of that would be, let's say you've got the receptacles serving the countertop in a kitchen. They're required to be GFCI protection in accordance with 210.8, but they also are required to be AFCI protected on that branch circuit in accordance with 210.12a. So how do you kill two birds with one stone? You put a dual function device in the panel, and it can serve the GFCI as well as the AFCI requirement. Now, could I put an AFCI breaker in the panel and put a GFCI at the first receptacle on the countertop and still meet that rule? Absolutely. That is also doable as well. Remember, the GFCI requirement is very much in 210.8 driven towards the receptacle, whereas the AFCI requirement for AFCI protection is driven to the branch circuit. Okay? All right. Anyway, we discussed that more in Chapter 6 as well. So basically, you can see how extensive our program is. We don't leave anything to chance. So Chapter 8 is going to discuss AFCIs and GFCI protection. It's going to have AFCI and GFCI requirements are discussed in Chapter 6. We might discuss that in a future video, but again, I just wanted you to see that you could click on this within the program and you can go to other areas within the course and really learn those details. Okay, so that's how extensive it is. For anybody that's interested in learning more in depth about residential wiring and to help reduce that learning curve, our residential wiring course is probably hands down the best out there because I also grade every one of your competency reviews at the end of a unit. So I can give you feedback and tell you what you're doing wrong, what you might be answering incorrectly, and I can even give you commentary. And that's what I'm here for. I'm here to be your instructor, and that's why you would get access to these courses through electricalinstructor.com. Because that's what we're doing. We're trying to instruct you in all the nuances of residential wiring, commercial wiring, industrial wiring, grounding and bonding, which is difficult for many people. We have a great course on that. Okay. Again, you can kind of get an idea how these courses go, right? All right. So I could go to Chapter 6 if I wanted to learn more in-depth understanding of AFCI and GFCI. Okay. So let's look at this right here. Now, where is the panel in our dwelling? And you'll see this in our example. We'll have a picture, a graphic. The panel is located in the basement. Okay, and so we're running our branch circuit or our home run, if you will, from that panel A to a certain point in the system. First junction box, first receptacle outlet, first switch outlet, wherever we're running it, lighting outlet box, wherever we're running that branch circuit to. Okay, so that's what we're focusing on. So the panel is in the basement in this case, and the circuit again is A19. That's the one that's running. So here's what it says. Because the panel board A is located in the basement below the wall switches next to the sliding door, the home run for circuit A19 is bought to the outdoor weatherproof receptacle. Now, this is simply a design choice, okay? It could have been bought straight up to the bedroom and taken into one of the light switches. It could have taken into a lighting outlet box. It could have been taken into one of the receptacle outlets. Whatever, the choice is yours, the design. But the reason it was done this way, and again, I helped author this book. The reason it was done here is to kind of, I guess, I should say, what's a good word for it? Subconsciously let you know that, can that outside receptacle also be on that bedroom circuit? Absolutely. Absolutely. But again, many people don't think about that. They think that, oh no, you got to have a dedicated circuit to all the outside receptacles. Not true. But we do it kind of subtly in our program to help you kind of understand it. So anyway, you'll see in a graphic in a minute where we choose to bring it in this graphic. Now, the result of that is 6 conductors in the outdoor receptacle box. Now, the home run could have been bought, again, to the corner receptacle outlet in the actual bedroom. That's true statement. Again, all about how you want to design it, okay? In this case, since the outside receptacle was right there, let's go on and hit it and get it out of the way, and then we go up and hit the bedroom circuit, the bedroom receptacles and all the lighting and all. It's just a design. However you want to do it, the code allows for it. It's not a big deal. There's nothing in the code that says that outdoor receptacle has to be a dedicated circuit. Now, the code says you have to have a receptacle front and back of the dwelling, but it doesn't say how they are supplied, okay? In this case, we're going to use that bedroom circuit to do it, okay? Now, again, it's a matter of studying the circuit, determining the best choices to conserve both cable or conduit or conductors, and what's the most economical route to take, okay? And you have to make your decision based on that. So in this case, we've got some figures we'll look at here as well, but in the electrical plans, it shows circuit A19, which is the one that's going to be going to our bedroom, has 4 split-wired receptacle outlets in the bedroom. Again, design choice, okay? 1 outdoor waterproof GFCI receptacle outlet. Again, we showed that's where we hit our circuit. That's where we started. That's just a design choice. And it says 2 closet luminaires, each on separate switches, plus a ceiling fan luminaire. We have 1 telephone outlet and 1 television outlet, which the telephone and television have absolutely nothing to do with, obviously, branch circuit A19. But when you look at the graphic, you're going to say, what are they? So we might as well explain it to you, okay? Now, all receptacles are required to be tamper-resistant type, and that course is covered in 406.12.1, and that will tell you that they're required to be tamper-resistant in this dwelling, okay? Now, they're tamper-resistant, not tamper-proof, okay? I get that a lot, so I just wanted to check. All right, so here's our layout. Now, here's your layout. Here's our home run, A19. And just because of location, because this is coming from the basement, we could have chose to bring it up in this receptacle if we wanted. This is closest to where the panel is, so this one was closer than this one, so why would I want to run a separate circuit for that? So we might as well just pick that up. It's going to be used very sparingly, so we might as well hit it there. And then you see what happens here. We ran up and hit the luminaire, and this is just a switch leg, okay? And we're running down with 3 wires, 1 because we want to get a hot here, so we can also power this light as well. So that's just a design. Could I have run what? I could have gone to this receptacle. I could have jumped over to this switch box and then have a single 14-2 coming here and a 14-2 coming there. Again, there's many ways to do this. This is just one way to do it, but it makes you really realize that in residential wiring, you got to think about it. Because if this is on a drawing for a commercial aspect, then you're just going to follow the drawings. But as a residential electrician, you have a lot to think about. You have to really think about how I want to route this circuit. And I can tell you, there is one nightmare scenario that runs through every electrician's mind when it comes to residential wiring. Did I feed every circuit? Did I leave anything dead? In other words, I forgot to loop in something so that once it's gypsum boards up and everything's finished, all of a sudden I have a circuit that's not working because I forgot to run a home run or I forgot to loop something together. It's a nightmare that electricians never want to experience. So it's important to really lay out your circuits and double check them before you say that you're done, okay, making sure everything works. All right, it's just a little tip to think about, because I have gotten calls from people that say, Paul, I forgot to loop in a feed to a set of receptacles. Nightmare scenario, because now how do you tell the owners, or how do you tell the general contractor that I got to come back and remove some gypsum board in order to try to get these circuits together? Maybe it's just as simple as easy as going underneath or above an attic, but now you have to think about how you do it, and nobody wants that nightmare. So just think about it. That's why I say this is a great example of a layout, because it's basically telling me that I'm choosing to do this in a certain way. And in this case, I'm choosing to hit the outside receptacle, and then I'm running both to the first receptacle in the room, or the switch box in the room, but I'm also going to go in and supply the luminaires in the closets, so that I got to figure out how I'm going to route this. And again, this would be a simple case of 14.2 here, 14.3 here, 14.2 here. That 14.3 allows me to get that neutral down as well as the hot down. Okay, so again, perfect scenario. This is just a way that makes you think. Now, in this case right here, you see where once it came from here, now this is why they said it ends up putting 6 conductors in here, right? You have a 14.2 here, 14.2 here, 14.2 here. Of course, you got an equipment ground. All count as 1 when you're doing that box fill, and the device is 2 double volume. So you have to think about that when you're doing this box, okay? Box fill. Hopefully you've watched our videos on box fill. Very important. Don't take it for granted. Just because a cable can make it in that box doesn't mean you can use that box, okay? Got to think about those things. So in this case, we're taking a 14.2 up from here, and we're going to hit this 2-gang box right here. Of course, right here, I've got a 3-way switch here. And as you can see, I've got also feeding this receptacle, which these are being switched as well. And that's why they're half broken, and that's why you see 3 conductors, because you have to have a hot that carries on, but you also have to have what? You also have to have the switched conductor in order to be able to switch these. Okay, so that's what these are. These are kind of half hots and half switched. Okay, I don't see a lot of people doing that today with all of them like this. Be honest with you, they're usually, well, once you have a light in there, then you don't have to switch any of the receptacles. Now, could you switch a receptacle in lieu of a luminaire in the ceiling? Absolutely. When it comes to the master bedroom, for example, that would be okay. The code allows that in 210.70. So I could do that. In this case, in our drawing, this is a kind of like I would probably wire up some of my high-end homes. I'm going to give you some switched receptacles, okay? But I'm also going to, in that process, I'm going to give you what? Some receptacles that are half hot all the time, which are required, by the way, for our spacing requirement, okay? Within 6 feet of this opening, I got a receptacle that I can go up to 12 feet, and I got this receptacle. I have to have a receptacle within 6 feet of this opening, okay? So that probably is. If I switch the entire receptacle, then I don't have the required receptacle within 6 feet and every 12 feet. So that's why I switch half of it. So I still have a receptacle there that meets the rule. But the other one is switched, and that's optional to do that if I want, okay? And, of course, here we have a ceiling fan, and there's a switch for the ceiling fan right here. So this is just how this room is laid out, okay? Here's the single for the light right here that's just outside. I guess this is a little patio that's going outside of the bedroom. And there's your switch for that light right there, just a 2-wire going up, black and white. Pretty simple, right? So in this scenario, this is a pretty simple layout. Now, if we were looking at cumulative loads, people ask us all the time when we look at cumulative loads, we like to go with what's called worst case scenarios. So when you see a receptacle at 120 watts each, remember, in commercial applications, we would use 180 VA per strap. Now, in a worst case scenario, and again, this is just to come up with estimated loads. When you're coming up with estimated loads, we typically use 120 watts each. For this, and where we get this from is 15 times 120 is 1,800 divided by 15 is 120. We tend to use the 120, although that is voltage, is why we're calculating it out. We typically use 120 watts each for the receptacles. Keeping in mind, this isn't a requirement. Generally, a receptacles inside of a dwelling you can have any number you want, okay? But for a load, if I wanted to come up with a load calculation, then typically I'm just going to take 120 watts each for the receptacles. How many receptacles? I'm going to count that. In this case, it was 4. So that would be 480 watts. And of course, we can count them. This is 1, 2, 3, 4. And the reason there's no receptacle here is because this wall space is not 2 feet or more. Okay, so there wouldn't be a receptacle here. Okay, you wouldn't put anything there. Okay, but just want to remind you, in the real world, the 120 watts per receptacle is not really something you do in residential. We're just using this as a theoretical estimated load calculation to kind of give us an idea of what our loads are on this branch circuit A19. Okay. Now, again, we do the same thing for the weatherproof receptacle. We're just going to use 120 watts. Again, use whatever you want. If you wanted to even use 180 VA, you can if you want, but that is commercial. That is not residential. Okay. We're just coming up with a value here. So look, I don't want to get comments in the notes that says, Paul, where did you come up with the 120 watts each? It is just what we've calculated out to use to come up with what's called an estimated load. Okay, it's all we're doing it just for this example. All right, and that's why you have these little asterisks here. If you click them, it says the NEC does not require a unit load for receptacles installed in dwelling units. The wattage of the lamps may be greater or lesser. That's when we're dealing with luminaire loads. Okay, these loads are included for illustrative purposes only. Please don't think that Paul said that every receptacle counts at 120 watts. We're just doing that to give you an estimated load calculation. Okay. I'm sure I'll get tons of emails for that, but again, I will file those in my delete drawer because, again, I've explained this ad nauseam why we did this. In real world, I could put 20 receptacles on a circuit and it wouldn't matter. We only really want to worry about the loads that we can calculate, and that is the wattages or the luminaires ratings. That is a load that we know is accurate because once it's on, right? But in order for us to calculate something, this is kind of what we've done here. Now, I'll click this, kind of show you what we've done here. And if you look at all the loads that are in that room, and I'm not sure if this is all showing up. Yeah, it looks like it is, pretty much. If you look at all the loads in the room, and we were to take those receptacles at 120, we took that weatherproof outside at 120. We had the outdoor bracket luminaire at 150. That's what the wattage was. We had the closed collet. We have a 75 watt lamp in each, so there was 2 of them, so that's 150 total. We have the ceiling fan light. There was 1 of them. So there was 3 50 watt lamps in there. And then of course we had a motor at 0.75 at 120. So it volts, and that is 80 watts. Okay. So we end up coming up with that. So we've got our values, and then we have a total load, and it comes down to our total value down here. Okay. All right. So there's our values, and we would just, now again, this is just for craps and giggles, okay, to try to determine what we have a load on that branch circuit. But in the real world, you do have to be very careful at the amount of load that you do put on it. So what I get from time to time is people will say to me, how many receptacles can I put on a branch circuit? How many luminaires can I put on a branch circuit? How many ceiling fans can I put on a branch circuit? So that's when you have to take all these things into consideration when you're doing your calculation. All right. So considering everything that's involved, then you have to remember all those things again, because we don't want to pull more load than we can on that branch circuit. So by assigning a certain value to the receptacles, because we don't really know what could be plugged in there, then at least gives us something to work with. And that's why we do it when it comes to an estimated load. Okay. I don't know how many times I got to explain that, but hopefully I did it enough. Now, in addition, an outdoor bracket luminaire is located adjacent to the sliding door, and it is controlled by a single pole switch within inside the door. We kind of saw that right here. There it is, and we're saying that's 150 watts is what they're saying. Okay. It says, note that the single pole switch device for the outdoor luminaire is located inside the bedroom. As a result, the wiring device is required to be protected by AFCI. Again, it's not just outlets, okay? It's not just receptacle devices. It's also switch devices that's located within the room, so it's going to require the AFCI protection. Of course, we already determined that AFCI protection is going to be on this branch circuit anyway. But this is kind of let you know. That's how we get there for that. So as a result, the wiring device is required to be protected by AFCI. The AFCI circuit breaker at the origin of the branch circuit does provide that protection for the entire branch circuit. Okay. Now you notice that we have those split wired receptacles. Okay. Split wired means the tab on the side is broken. The neutral side's not, but the tab on the hot sides or the ungrounded conductor sides is broken. Okay, so we're using that red, let's say, as our switch, and that's switching the top or switching the bottom, and the other one's going to have the black that's going to be hot the whole time. Now, people ask me all the time, which orientation should you put the receptacles in? And it really doesn't matter. Either ground up or ground down, the code doesn't care. Doesn't care. Now, in commercial applications, there has been some arguments that, let's say I'm using it in a commercial environment where I have metal cover plates. And those metal cover plates come loose and I have something plugged into it. If you have the grounds down, then that metal cover plate could slide off and slide down and cause a short. If there's a gap between the attachment plug and the actual receptacle outlet, that it could cause a short, and that would actually trip a breaker. Now that's true, and that's why we have overcurrent devices. That's why we have that in place. But if you had to turn the grounds up in that scenario, then if the plate came down, it would just hit the ground pin, and it wouldn't short out. Okay, not a code requirement. Might be a local jurisdictional requirement, AHJ requirement, because they can supersede the code, but it's not an NEC requirement. It's just general conversation. That's all it is. All right, now, the split wire receptacles are controlled by two three-way switches, and as you saw here in the example, one on this side of the room and one on this side of the room. Okay, so that's where you're going to see that controlling of those split receptacles. Okay, one is located next to the sliding door, as the front bedroom, living room, and study bedroom. The use of split wired receptacles offer the advantage of having switch control of one of the receptacles at any given outlet, while the other receptacle remains live at all times. Again, like I said, a duplex is two receptacles. You have a top or bottom, whichever one you want to switch, have at it, okay? Do whatever you want. But that's what that's all about. And again, if you don't understand that, the beautiful thing about our course is that you have all these graphics that you can click on, and you can go back and it will talk about other requirements in the code. See this graphic? It will talk about it, and you'll be able to anytime read and see what it requires, okay? Another example would be here is 12.15 will give you a definition of what exactly a receptacle is, okay? A device, okay? So anyway, great way to jump around in our course. Now, next to the bedroom door are a three-way switch and a ceiling fan light control, which is installed in a separate 2-gang box as shown in illustration 9-2. So looking at this drawing right here, we have two separate boxes, okay? Two separate layouts. And I'm going to let you see what that looks like is if you were wiring it up. And here it is, okay? So you see here, we've got the conceptual view of what we're talking about. We have that three-way right here. And then over here, we had that to this. This goes up to the ceiling fan light combo. And this goes down to the receptacles, okay? So this goes to the other receptacles. This goes up, providing what? Power, continuing it up. Okay, now why do we need the three-wire here? Well, we're going to switch part of this receptacle like we did on all of them, but since we're feeding this 2-gang box from here, and what we want to do is we want to make sure that we bring over 3 conductors, a 14-3, for example, because we're carrying over the neutral, we're carrying over the hot, and we're carrying over the switched. Now, the switched one stops here. Okay, let's say it's the red conductor. But the black and white are going to continue on up to this double gang box, where it's going to end up controlling the ceiling fan and the ceiling light. Now, this three-way here, that was going to be a dead end. That's where it stops, okay? So if I showed you that here, this is where it stops right here, because the three-way goes from here to here, and that controls these receptacles, okay? And so no matter where you put a lamp, let's say, you'd be able to control it, okay? All part of your design, however you want to do it, okay? Now, let's talk about that sliding glass door versus fixed glass panels, okay? Now, receptacles inside of that bedroom. Now, you heard me talk about the 6 foot, 12 foot rule. You probably heard it many, many times. And that was based on the layout. So we'll kind of go back a little bit and look at the layout, but let's read what it says here so we understand when we're laying out those receptacles in that bedroom, how we do it. It says sliding glass doors and fixed glass panels. So in a sliding door, you have one portion that is fixed and you have one portion that slides. Okay. All right. The fixed portion, the part that does not slide, that acts like wall space. Okay. The portion that slides is not. That's the break in the floor line when you're doing your measurement around the floor line. Let's read what this says here. It says, receptacle outlets must be installed so that no point along the floor line in any wall space is more than 6 feet measured horizontally from an outlet in that space, including any wall space 24 inches or 2 foot or more in width. Wall space occupied by fixed glass panels in exterior walls is considered to be wall space. Sliding glass panels are not considered to be wall space, the same as any other interior or exterior door. So an opening is an opening. So just because it's a sliding portion on it, it's still an opening. But you measure from the point where the fixed glass starts. And you have to have a receptacle within 6 feet. And then you can go up to 12 feet because anywhere along there, if you went all the way to the middle, then you would be within 6 feet of the one. And if you put one right at 12 feet from the other one, then you would be within 6 feet of that one. Okay. So I get that question a lot. What is the maximum spacing between receptacles in a bedroom wall? That would be 12 feet. Why? Because at no point along the wall line can I be more than 6 feet from a receptacle, right? So 12 foot, I put a receptacle right in the middle. Isn't it within 6 feet of that end and 6 feet of that end? Absolutely. So that's how the rule works. Okay. Now, because fixed glass panels are considered to be wall space in a master bedroom, a receptacle must be located, again, that's not more than 6 feet from the edge of the panel. Now, let me see if it shows a graphic. It does not, so I'm going to go back so that we can use my graphic here. So here we go. This is the sliding portion. This is the fixed portion. So I'm going to measure from right here. Right here. This receptacle here can't be more than 6 feet from right here. Now, I can go up to 12 feet this way and put a receptacle because anywhere here that I were to put my finger, I would have to be within 6 feet of a receptacle. Okay. Now, if I put it, can I put it less than 12 feet? Absolutely. If you want to put one every 5 feet, 6 feet, 7 feet, whatever you want, that's your design. Okay. But if I go the maximum 12 feet, then any point on this wall would be within 6 feet of a receptacle. Now, we got to keep in mind when we're designing this, because let's look at this wall real quick. What if I moved this one right here? It might be this one within 6 feet. Maybe I put it back here, but then I go 12 feet and it's right here. Well, here I've got to have a receptacle within 6 feet of this break in the wall line. So if the receptacle, this one was still back here, then I would not have a receptacle here. I got to add another one. So that would result in having 3 receptacles on this segment between this opening and this opening right here. That's okay. That would be code compliant, but it's all about the spacing. And you as an electrician want to space things out as neat as possible, right? So in this case, I'm going to go probably the maximum 6 feet. And then I'm going to go the maximum 12 feet. And if my receptacle at that maximum 12 feet still is putting a receptacle within 6 feet of this opening, then I'm okay. But if you want to add another receptacle and space it out or whatever, that is totally up to you. I'm just telling you what the code minimums are. Okay, you with me? All right. Now, why is there not a receptacle here? Because this space is not 24 inches or greater. Or this space is not 24 inches or greater. Okay. Now, could I put one back here? Yes, if you want to. Could I put one in here? Yes, if you want to. Knock yourself out. It's just not required by code because the plausibility of putting anything here is just not there. Now, some people would argue that if I put one right here, it would probably get used more than any receptacle in this room because the furniture would be blocking these. And if I'm going to plug a vacuum cleaner in, that's where I would plug it. Okay. Makes sense, but it's not the code. All right. Okay. So anyway, that's kind of gives you an idea of how the receptacle layouts go. Another tip I'll tell you is if this door right here happened to swing in, And again, this is a bedroom, so it's swinging out for egress. But if it was swinging in, for example, okay, and it could, then the receptacle, I would measure back just far enough that that receptacle is not behind the door. Because more often than not, that door is going to be open, and it creates a receptacle that's pretty much useless behind the door. So I would want to come out at least just past the door. Be honest with you, I'm going to go out to what the code allows me, the maximum. I'm going to go out 6 feet, unless it kind of screws with my layout. And then I got to look at the layout of the wall. Okay, I'm never afraid to add additional receptacles. They add very little cost to the job, but it might be a convenience thing, and it might separate you from the low-end electrical contractor versus the high-end, which doesn't nickel and dime your customer. But again, that's your decision. I don't get into the cost aspect of that. It's just things to think about. All right, so let's talk about the selection of boxes. Okay, so we discussed this back in Chapter 2. So if you're in our program, you remember that we had Chapter 2, and that's talking about selecting outlet boxes, switch boxes, what we need for the certain job at hand. Okay, now I will tell you, I'll give you a little hint. I never use metal boxes if I can help it. I always use plastic boxes. Why? Because one, obviously I don't have to bond the plastic. Okay, it goes without saying, right? When you have a metal box, then you got to worry about bonding to it and all this type of thing. So again, it's just a step that's not necessary. Now, I understand that metal boxes might be all you got. Okay, I get it. Just make sure you watch our grounding and bonding courses to understand equipment grounding conductors and how you have to bond the boxes and all that kind of good stuff. But if you have plastic boxes, it makes it a little easier, okay? But anyway, let's look at our requirements here. And there's some good practice and some good common sense things that you have to think about. Now, for example, in the master bedroom, in our case, the electrician may decide to install a 4-inch square with a 2-inch a 2-gang raised plaster cover at the box location next to the sliding door, or 2 sectional switch boxes ganged together may be installed at this location, and typically those would be metal. And again, also the 4-inch square with a raised cover would probably be metal. Would not be my choice. But that's a design, that's up to you. Now, a 2-gang non-metallic boxes are readily available and are particularly suitable for branch circuit wiring using non-metallic cable. And that's typically what I would use. But again, have at it. Just remember all the rules with metal boxes, clamps, taking the NMB in at least 1/4 of an inch beyond the clamp into the box and bond the box. And you get it? Okay. All right, so let's look at our options. So this was one option here. Now, this shows 2 switches and a wall plate that attaches to a 2-gang 4-inch square raised plaster cover, or to 2 device boxes that have been ganged together. Okay, you could do that as well. That's here. So this could be a 2-gang metal box, 2-gang 4-inch square box, or 2 singles that gang together are gangable boxes. Those typically would be metal. And again, since we're talking residential and most of the time it's going to be commercial, I like non-metallic. Now, you could be doing MC cable. Makes sense then. Metal boxes, there you go. Okay, now, B and C show 2 interchangeable type switches and wall plate with attached to a 1-gang 4-inch square raised cover or to a single device switch box. Okay, these types of wiring devices may be mounted vertically or horizontal. So in this case right here, you see that I have a switch right here, and depending on how you mount it or how you orient it, okay, you've got these boxes. Now, you got to be careful with a couple things. When it is a switch with the on, it should be on in the up position. But a lot of, the switches like that, three-way switches won't have any markings. Really doesn't matter. Just be aware of what you're doing, what you're selecting, and how you're doing it. Okay, but there you go. There's some. Now, height and standards boxes. Again, we don't need to go over this. A lot of this is covered in 314.16 when it talks about standard boxes. The metal boxes are in the table, but a lot of your non-metallic boxes are going to be marked inside. And of course, we cover that back in Unit 2 or Chapter 2 so that you understand all the nuances about boxes, okay? So I'm not going to rehash this again, 314.16, Chapter 2. If you're in our program or if you're in the residential course, I think you see by now, we cover this stuff in extreme detail, And that's what that course is all about. And of course, we do show you how to do box fill and everything like that. So that brings me to another thing. Every box that you put in a dwelling, and we're talking dwellings today, residential, you're going to have to understand the number of conductors that you place in that box. And so you really do need to understand box fill. You have to understand that a receptacle is a double volume count. You have to understand that a clamp that's inside of the box, if it's a metal box with a built-in clamp, for example, that has a 1 conductor volume count. Okay, it takes up space. It takes up volume in the box, and you have to account for that. Even the dividers that might divide a 2-gang box into 2 singles, but it has a divider in the middle, it takes up a certain type of volume, whether it's metal or non-metallic, and you have to be aware of that. So being a residential electrician, and we cover all that in this course, it's really a lot of information for you to be able to digest. And what we're trying to do in this course is really teach you all those things that would take you quite a long time to learn. And we're condensing it down so that you learn it piece by piece by piece. And that's important, okay? So again, you see here that we even talk you through how to determine a box fill calculation. And again, here you've got all of it. It covers everything. The switches, and again, double volume count for your 2 switches. In this case right here, 2 switches. So it's a double volume count for both. Okay, so when I say double volume count, let me make that so you understand. If you go to the table 314.16 and you look at the table and you see a 14 gauge conductor. Now, a 14 gauge conductor would have a 2.00 cubic inch volume allowance. So if 14 gauge goes to this switch, then it's a double conductor volume allowance. So it would be 2.00 for 1 conductor. If I had 114 coming in here, 1 black conductor. But since this is a device, it's a double volume count. So it's 2.00 times 2. So it's a 4.00 volume count, cubic inch, for each one of these devices. Okay? And that's kind of what it's talking about down here, see? Now, this says 2 plus 2. That's a double volume count. Now, another way to look at this is when we say double volume and you're adding up the number of conductors, 1 bare conductor coming in, and you learn this in the course, if you don't have more than 4 equipment grounds, it counts as 1 conductor. And if it's 14 gauge, it would be 2.00. If there's 14 and 12 gauge in the box and you use the larger, okay, that'd be 2.25, I believe, for 12 gauge. Now, the point being, if I tell you that a receptacle or a switch has a double volume count, then it actually equates to 2 conductors. Now, if I want to tell you what the actual cubic inches are of that double volume, then it would be 2 conductors, right, per device, and it would be 2.00 plus 2.00. That's 4.00 cubic inches for each device. And that equates to 2 conductors. That's why we call it a double volume count. Okay. So anyway, we cover all that in the course, but I really want you to understand that box fill is important. Even in residential, it's not just a commercial thing. You can't just jam a bunch of conductors in a box, and we show you how to do that in this program. Okay. All right, let's talk about suspended ceiling fans because we have them in our master bedroom. Okay. And so here's what it says. For appearance and added comfort, ceiling suspended paddle fans are very popular. Absolutely. I don't know many bedrooms, especially masters, that would not have a ceiling fan in them now. Okay? They're very popular. So, ceiling suspended paddle fans rotate slowly in a range of approximately 60 revolutions per minute to, again, on high, 250 revolutions per minute, depending on how you set it, low, medium, high, okay? Without forcing air movement, warm air rises to the ceiling and the cool air drops to the floor. Again, hot air rises, cool air sinks. So what do we do with the ceiling fan? Again, what we're doing is taking it, and when that hot air rises, the ceiling fan is pushing it back down, okay? Those type of scenario. Now, when cold air sinks, we want to reverse it and we want to pull it up so that we can have it circulate throughout the room. So again, that's why we change directions on ceiling fans. And I'm not an expert on airflow and direction or whatever like that. I know most people put their ceiling fan in and they just leave it. As long as it's blowing on them, they're happy, right? But again, you can change directions, again, depending on the different times of the year. Okay, now, Fans are hung in ceilings are not quite as efficient in moving the air as those that are suspended a few inches or more from the ceiling. Again, the closer it is to the ceiling, it's harder to move that air. So when you usually extend them down, it moves air a little more efficiently. However, many people like them to be tight to the ceiling huggers, and that's perfectly fine. It'll still work. Again, this is a convenience thing, but ceiling fans are extremely popular. This is an example of one here. This one does not have a light kit on it. Many times they do have light kits on it. Most of the fans, again, have reversing switch, as we just talked about. They got medium, low, and high, and they have an off position. Most of them are going to be controlled by a rheostat at the wall rather than trying to pull the cord. But again, all part of what you choose in your layout. Upscale models have remotes as well, and some of them even allow you to dial the speed in to fall anywhere in a range, so it's not a predetermined low, medium, and high. You can control it up and through the spectrum, some of those high-end ones. And to be honest with you, a lot of the ceiling fans today don't even have switches on them. They're all done from a remote. Now, you'd be crap out of luck if the remote breaks. Yeah, you can get a replacement, and then you'll have to go in and make sure it's on the same channel. But again, a lot of them don't have the pull chains anymore. Okay, if they're and a lot of my fans in my house, they don't have pull chains. They don't have reversing switches. Everything's done through a remote. Some people like that, some people don't. Now, the other thing about this is with the remote controls now that are on these ceiling fans, in the past, you had to have a certain type of box that is self-supporting of that ceiling fan when you had that extra wire up there, like that third wire or that red that was capped off. If you bought it there, then you had to use a box that could support the weight of a ceiling fan. Well, the code changed and said, look, we're not going to require that. Here's what we're going to do. We're going to tell you that if you have a location in a habitable room where if you could put a ceiling fan in there, then it's going to have to be a specific type of box to support that weight. Unless you have the ability to get to that box at a later date, say it's above a suspended ceiling or above the attic space or whatever. But up front, we're going to say, look, since now we have ceiling fans that you could run a 14.2 up to and not have to have the third one to control the light separately than the speed because of a remote, well, that's why we got rid of that requirement when you had to have that extra wire there. Because now I could put a ceiling fan on any light box in my bedroom, even if it was only a 14.2 there. But I got to make sure that box can support the weight. Okay. So with this code changed a little bit and said, look, we're going to do this. If you have a ceiling box, a ceiling lighting outlet, and it is in a location in a habitable room, and of course, habitable rooms are now defined in the NEC, Article 100, check it out. If it's going to be in that location, then that box has to be able to support the fan weight, or you have the ability to get to it at a later date, okay? And that would be like an accessible attic or in a drop ceiling or something like that, okay? There's nuances in that rule, but that is how it is now, okay? So it doesn't matter whether you run a 14.3 up there or not, like it used to be. Now it's going to be a 14.2 up there if that ceiling fan is in a location where it could plausibly put a ceiling fan. Now, if that light box is like for a sconce or track lighting that's over near the wall, then it would not require this because the blades would hit the wall, okay? So that's the allowance that says, you know what, that's not plausible. But anywhere else, if you could put a ceiling fan there and the blades wouldn't be inhibited, then you're going to have a box that supports the weight of the ceiling fan. Okay. And of course, we talk about that throughout the unit, and many other units get into a lot more detail than that, but I just kind of wanted to give you that thought. Okay. Now, this is something that's probably a little extra that we do. I just want you to know we go extremely in depth in this program. Why? Because you get to share with your customers all of this information. And this information is really good for them because it can show them how to get the best out of their installation. Now, this is what we kind of talked about earlier, is it says the major manufacturers of the ceiling fans recommend directing the airflow downward clockwise in the summer and from the benefit what's called the wind chill effect by blowing on you, and upwards in the winter. Why? because it blows that heat and moves everything around. Okay, that's what they recommend. Okay, so where that heat rises, it sits at the top. We want to make sure that it blows around. So even I have to review this because I get confused because I probably said it backwards earlier. I probably did. So in the summer, I like to feel the breeze, blow it down. In the winter, don't need to blow on me. Okay, heat rises, it sits up at the top. So let's have it blow it upwards so it kind of moves that warm air out and circulates it into the room. How's that sound? Easy to remember. In the summer, chill me off. In the winter, recirculate it. Okay? Anyway, some people do the opposite. I grew up people doing the opposite with that. Okay? So that was blow it up. It pulled cool air up because cool air sinks, but the manufacturers say differently. So again, is there a right way or wrong way? I don't know. Some people like air blowing on them at all the time. Some people don't. So again, many people just set it one way and never change it. Okay. Now, at the end of the day, these are only manufacturer suggestions. Again, you can do whatever you want. But again, for rooms, to kind of let you know what's the size that you would need for rooms, a 144 square foot room, a 42 inch will be adequate. A 225 square foot room, a 44 to 48, 400 square foot room, 52 to 54, and a 500 square foot room, a 56 inch fan will typically do the job. Okay. Now, again, this is kind of gives you what they recommend. Okay. Again, do whatever you want. I was always taught differently, but here you go. So in the summer, they want you to blow it down on you. That wind effect, cool you off. You know, summer breeze. I could sing a song, but y'all wouldn't like that. And in the winter, since the heat does rise, their belief, the manufacturer, is that let's take this heat that's rising and let's recirculate it down into the room so it gets the room circulated heat. Okay? There you go. Different ways, different strokes for different folks, but that's the manufacturer's recommendation. Now let's talk about those supported ceiling fans. Again, we kind of touched on it. Since we're working all the little nuances of the master bedroom, let's talk about the ceiling fan. It is a very important issue here that we have to discuss. It is. There have been many reports of injuries, contusions, concussions, lacerations, fractures, head trauma from ceiling fans falling out. And I'm going to give you a little story. In my house, which I did not wire, I moved to Texas, I bought a house. I'm in my studio, and my ceiling fan literally falls out of the ceiling. Now, good news for me, it was connected onto a clamp. They used a metal box, and it actually held it. The cable held it from falling. It literally fell out of the ceiling. What I found out when I went up there was that they used a winged retro box, which isn't designed to support the weight of a ceiling fan, and there wasn't a ceiling fan in here before. But they put a ceiling fan in here, and that was the wrong box. So obviously, I rewired it. I put the proper box up in there. I put the proper ceiling fan box to support the weight, and now we're all good. But the sheer fact of the matter is I was sitting here one day doing a recording, and a daggone ceiling fan was going, and in the inertia, it just came out of the ceiling. I'll remind you, I did not wire this house. So there you go. So anyway, very important to understand it because they can. Now, there have been reports of ceiling fans falling out of ceilings because people put them on just, look, I get it. A lot of people will go to do a service call and somebody wants to put a ceiling fan up. I get it. So they go in there and they take the old light down and they notice it's just a plastic box up there. Nobody's looking. They figure those 832s will hold it. They put the fan up. It seems tight. They walk away. Well, over time, those screws will strip out and, again, could fall down on somebody. I don't want that liability. I'm getting paid to do a job, so I'm going to go in there and I'm going to actually put the right box in there. I'm not just going to take the money to put a ceiling fan up. I'm going to do it right. Okay, that's just me. You do what you. But we're talking new installation, but again, I felt it was important to kind of touch bases on that. Now, ceiling fans have fallen out of the ceiling. I witnessed it. I have had reports of ceiling fans falling in the baby's room, and the only thing it kept it from hitting the baby was the sides of the crib, things like that, because the baby was down in it, and the blades caused it from falling all the way in. Look, they do happen, okay? So there is also a possibility of starting an electrical fire when the wires of an outlet box and a fan canopy short circuit as the fan falls from the ceiling. Yes, that could happen as well. As they start to pull away, it puts stress on those conductors and they end up coming apart. And yes, a fire could start depending on what type of ceiling you have, what type of, maybe there's insulation, maybe it's that blown in, maybe it's old cellulose or something. I don't know. But there are reports that it has happened. Okay, so better safe than sorry. Now, these problems are usually traced back to an improper installation. And in my case, absolutely was an improper installation. Now, the safe supporting of a ceiling fan, paddle fan, involves 3 issues. Number 1, the actual weight of the fan. Number 2, twisting and turning motion when the fan starts. So there's that initial torque that takes place when a fan starts. And of course, there's vibration. Not every fan is balanced. It might look you have a fan that kind of makes a warble sound or whatever. And we do our best to balance it out. But if a fan is not perfectly balanced, it creates this vibration. And again, 632s that are only being held in place, or 832s, if you will, that are only held in place, let's say, by the 832 thread count, then it could cause them to wear loose. And that's a big problem with plastic boxes. Okay, so here's the scoop. Here's what the NEC says. And here's what you need to do in a master bedroom if you're going to install a ceiling fan box. Okay, so these requirements are found in NEC 314.27c and in 422.18. Now, 422 is dealing with appliances, and 314.27c is dealing with the boxes itself, the outlet boxes design or outlet box system, because you can buy those systems with the brackets and the boxes and everything that would support a ceiling fan. Okay, so here's what we must think about. The outlet box or outlet box system must be listed and marked as acceptable for fan support. So always look for that on a product. Okay, always look for it if that's what you're going to use it for. It needs to be marked on there. It also is permitted to be metallic or non-metallic. They make both of them, so don't think that this is just a metal box thing. There are plenty of plastic boxes. In fact, you've probably heard me talk about in my bathroom video, whereas I used to use the plastic ceiling fan boxes that have the space in the middle for the 2x4. I would use those because you can center those on a stud, but those are non-metallic, and they can also support a ceiling fan because you drive 2 screws up into the base of that box, and it can easily handle the weight of a ceiling fan, okay? Or a heavy luminaire. So again, it can be plastic or it can be metal, not a problem. It must not support more than 70 pounds. So the general requirement is that the boxes that are acceptable for fan support are designed to not support more than 70 pounds. That's the box, okay? Now, if it's designed to support more than 35 pounds, but not more than 70 pounds, again, must not support more than 70, but if the box itself is marked and designed for 35 through 70, then it will be marked as acceptable for fan support up to 70 pounds. Okay, so that's important, that marking. Okay, now, has a weight limitation that includes the fan and the light kit. Okay, so again, when you're thinking about the fan and you're going to put a light kit on it, remember, it's not just a fan. That box is supporting both the fan and the subsequent light kit if you're installing it. So you need to take both of those into consideration. And you'd be surprised, some of the light kits are pretty heavy. So you need to take both into consideration. And lastly, with that part of it, of the first component, is you need to make sure that you follow the manufacturer's instructions. Now, even ceiling fan installations and how you install them, they have instructions. Now, they're a part of their listing. Many people throw those away. But if your inspector ever came on site and said, you know what, I want to see the instructions for the installation of that ceiling fan, they have every right to do that. And they could require you to show that. So I wouldn't just toss them, okay? Put them in a kitchen drawer or something like that. Put them away so that the homeowner has them in case you get somebody that asks about them. You want to make sure that you have it available. Now, I am sure that if you're like me, I've installed so many different ceiling fans, but even today, I still get a ceiling fan where I look at it and go, crap, I need the instructions because this is not like the last one I installed. Okay. Now, the concepts are pretty similar, but there's so many different designs with ceiling fans today. Again, we want to make sure we do it right, and we don't want that thing falling out of the ceiling, that's for sure. Okay. Now, let's look at this. This is kind of new for 2020, and this is extremely important because previous to this, remember what I was talking about? If I had a habitable room, let's say a living room, no, let's use our master bedroom. If I ran a 14.3 up there where I had a black which is the hot, the white, which is the neutral, and the red, which was maybe controlling the fan, whereas the black was controlling the light component. If I had that extra spare up there, then I had to put a box in there that was designed to support the sole weight of a ceiling fan. Okay, that was the trigger. Well, we've changed that into 2020. Now we're saying, look, with the advent of remotes, there's no need to have a 14.3, let's say, running up there now. We can do this with a simple 14.2 because we got a remote that can do the speed and a remote that can do the light. So we don't need to have that in the code. But now, since we know that could take place, we had to change it a little bit. So here's what the code says. It says outlet boxes mounted in the ceiling of habitable rooms, and of course we have a definition of habitable room, go look at it in Article 100, of dwelling occupancies in a location acceptable for the installation of a ceiling suspended paddle fan shall comply with one of the following. Now, what's acceptable? A location that's acceptable. Well, this is what's causing a lot of debate. And I'm going to tell you right now, any outlet box in a ceiling that has the clearance to allow you to put a paddle fan in it, like a 48-inch or 52-inch paddle fan, that is going to be acceptable installation for a paddle fan. I'm just saying. So that would require you to meet either one or two of this rule. Now, as I said, if I have a track lighting box, outlet box, that track lighting luminaire is going to go on, and it's close to the wall, then it's not going to be acceptable for me to put a ceiling fan there because the blades would never be able to spin. That needs to be your guiding rule. I had another person ask me, okay, what about in a room where I might have pendant lights hanging down? Okay, well, if I had pendant lights hanging down, they might say, well, I can't put a ceiling fan on the middle one because let's say I have 3 pendant lights hanging down because the blades would hit the other cords of the pendant lights. That's true, but could you not cap off the other 2 and put the ceiling fan in the middle if somebody wanted to? Absolutely. It is very plausible to do that. So that I'm going to say in my jurisdiction, I'm going to require those boxes to be rated to support, to be a sole support of a ceiling suspended paddle fan. That's how I would do it. Okay. But again, AHJs are going to have to give you guidance on this. But again, if it's acceptable, I mean plausible to actually put a fan there and it wouldn't inhibit the blades, then it's going to be required to be either one or either 2 of the rules that we're getting ready to look at. Now, here's what it says. Number 1, be listed for the sole support of a ceiling suspended paddle fan. So if it's an acceptable location for installation, somebody could put a paddle fan there, then that box has to be listed for the sole support of that ceiling suspended paddle fan. There you go. So yes, all of those installations, let's say in a 2-story unit, the first floor, which has a ceiling that is actually closed ceiling, all those lighting outlet boxes that are going to potentially could have a ceiling fan in it at some point in time are going to have to meet number 1 here. Listed for sole support of a ceiling suspended paddle fan. Okay? No way around it. Again, only applies to habitable rooms, so make sure you understand what a habitable room is. Now, option number 2, because it says comply with one of the followings. Now, number 2 says, okay, well, an outlet box complying with the applicable requirements in 310.27, okay, and providing access to structural framing capable of supporting of a ceiling suspended bracket, fan bracket, or equivalent. Okay, so again, this is how it reads in the 2020 National Electrical Code, and it's saying, look, I'm going to put in a sole supported ceiling suspended paddle fan box. However, what if I'm on the 2nd floor and I've got an installation where I do have access to that framing members at a later date because I could go through the attic? Well, if that's the scenario here, then I would just put an outlet box that has to comply with the general requirements of 314.27. Okay, we're in C right here, but the general requirements of 314.27, and I have to provide access to the structural framing capable of supporting the ceiling suspended fan bracket or equivalent. Okay, so you can buy these little kits. That is going to be one where people are going to be very touchy about this rule because some people will say, well, if I were to go and take, and say it's in the 1st floor and I have a 2nd floor and I have the closed ceiling, couldn't I take that down and then take that box out and put in one of those twist style? That's what they're going to argue, that you could do that. I think this rule was meant to say, no, those you're going to put a properly typed, sole-supported type ceiling fan box. However, on the second floor where you have access from an attic, that you can get access to the framing members, then you can just use a typical outlet box that complies with 314.27 because there is access to the structural framing. Okay, that's how I'm going to read that rule. Every jurisdiction is going to look at that differently, and I'm not here to tell you anything otherwise. So this requires an outlet box that is suitable for ceiling suspended pedal fan support to be installed for future use if a fan is not to be installed at the time of the rough-in, but it could be installed at a later date because there is nothing that would inhibit that, the blades or anything, as long as it's in what's considered a habitable room, okay? Interesting change. Many people are going to look at this differently, and it might even be some kind of public input for the 2023 coming on this, but there you go. All right, so what is an outlet box system? Because I am sure people have asked me, because you know what an outlet box is, but what is an outlet box system? Well, an outlet box system is an outlet box that comes with the bars, the straps, the hangers, the clamps, or other types of mounting hardware. I'm sure you've seen it where the box has a bracket and the box will slide left or right so that you can put it between the joists or between studs to center it up wherever it needs to be. That's an outlet box system, okay? Now, in new work, this is new construction, it says, install ceiling boxes marked acceptable for fan support in all locations where it is likely that a ceiling suspended panel fan might be installed. This generally includes all habitable rooms. We kind of covered that. This is new installation. Now, it says ceiling boxes installed close to the wall, in hallways, in closets, because those are not considered habitable rooms, by the way, and similar non-habitable rooms, and ceiling boxes installed for smoke alarms, fire alarms, and security devices do not require fan support boxes. So that's a good thing because people are also starting to ask, do we do that for the fire alarms that are mounted in the bedrooms and in the halls and things like that? And the answer is no, okay? Doesn't apply to those. Those are not considered lighting outlet boxes, okay? So those are outlet boxes. Those are ceiling outlet boxes, but they're designed for the smoke alarms, fire alarms, security devices, and things like that. Oh, incidentally, when I say this, we should probably clarify. Smoke alarms are not what you're going to see in a dwelling. They're going to be smoke detectors. Is that true or false? You're right. Smoke alarms are what you would see, as it says here in the text. Smoke detectors are what you would see in a commercial application, okay? Because they detect smoke and send it back to a central station. Smoke alarm is an audible device that would be inside of a dwelling unit, okay? Didn't want to trick you there, but I just wanted you to know that it is a smoke alarm. What you see in your bedroom, what you see immediately adjacent in the hall, those are called smoke alarms because they emit an audible alarm. A lot of people get them confused. What's a smoke detector? What's a smoke alarm? Okay, and I wanted to test your knowledge. All right, so some electricians are tired of trying to outguess what is likely and what a homeowner might do at some later date because we have no idea what they're going to do. So they install suitable fan support outlet boxes for all the ceiling outlets other than those that are clearly intended for smoke alarms, fire alarms, security devices, or those that are really close to the wall, whereas it would not be plausible to put a ceiling fan in because it would just beat the wall to death, right? Okay. Now, what about old work? So, when replacing an existing luminaire with a ceiling suspended paddle fan, like what we had to do in my office, okay, but at that point, it was already a ceiling fan there, so obviously somebody didn't follow the code, and I am in Texas, so I know that they were on the most recent code. This house isn't that old, okay? Now, but in older homes, it is unlikely that you will find this marking. You're not going to find those boxes. So as a service electrician, you're going to go out to hang a ceiling fan, and I'm sure that if you're on these apps like Nextdoor or I guess the Home Depot app where they send you out to, somebody goes and buys a ceiling fan and then they call you and want you to install it in their house, chances are you're going to get a ceiling outlet box that is not designed to support this ceiling fan. So you're taking a big chance if you secure that ceiling fan to an outlet box that is not listed for its purpose. It might hold it when you leave, but if it ever falls down on you, And I know you think you're perfect, and we all do. But if it does ever fall down, and let's say somebody gets hurt and they call somebody like me, expert, and I find out that you installed it without putting the proper box in, we're coming after you. Okay? We're going to get you. All right. So it might fall on somebody's head, obviously. And again, also, maybe you're doing this in a part of the country that has earthquakes or ground movement. And again, that movement and that weight and that inertia will loosen those screws. It could strip them out and that would fall. Okay? Don't want to take those chances. Follow the manufacturer's instructions. Do it right. And you don't have to worry about anything happening because of that. Even if it does happen, you're protected because you did it at the minimum safety standard. You can't be accountable for things you can't control, but you are accountable for things you can control. Okay? So here is a system. So there's an outlet box, and in conjunction with this bracket, this would be an outlet box system. And of course, it has mechanisms that go over the bar and hold it, and it's designed to support the weight of this ceiling fan. There you go. Okay. And here's an example of a hanger designed to install it. And this is kind of the retro design. Sheetrock's already up. And you see here, you take the box down, you reach up, you put the bracket in there. The bracket has a holding clamp, and then you mount the box to it. This is also a hanging assembly. This is more like a remodel assembly. And of course, there are also other designs that go on the end of a stud. So one of the aspects that I used to do when it was an open attic, that I would get a box and I would get the kind that slide over the 2x4. They had plastic ones, they slide over it, put the screws in it to hold it. And then I would go up in the attic and I would put the 2x4 and measure it and put it between the joists and then nail it from the attic. And that's what I'd do. Yes, you got to crawl in the attic and do it. But again, there are some other types of installations that you can do as well. There's hangers, and these are adjustable. So there's options for you out there. Okay. And this is another example right here. This is a special outlet box. It's designed to support luminaires and ceiling fans. It is welded. Okay. And it actually is a metal bracket, and you actually screw this metal, but you see it has these separate supporting components here that allows to screw in and support the weight. And again, it uses 832s. And then some of the other ones are tapped for even 1032s, okay? So again, 832 for the luminaire, 1032 for the actual suspended ceiling panel fan. That's basically how this device is listed for use. And this would be fine to mount up and support the weight of a suspended ceiling panel fan. And of course, you see it's got all the markings right here inside of it as well. Now, one of the interesting things that came out a couple cycles ago was a supporting device that is actually a receptacle that goes up in the box, and then we have an attachment fitting that actually mounts to the actual luminaire or ceiling fan. Now, these are pretty neat in the fact that you put this in the box, okay? So it is like a receptacle. It is classified as a receptacle, and this actually goes up into the box, mounts on the box, and then you put the attachment fitting on the actual luminaire or to the ceiling fan, and it actually has little teeth in it that actually these teeth will make contact in here. So it's basically like a receptacle. And what it does is it makes connection, just like a receptacle. And there's no wiring to do. You simply run the wires from the luminaire or the ceiling fan into this attachment fitting. And then you take the wiring from the actual outlet box and bring it into this receptacle. And then they mate together. And it's designed to support the weight. And where do you find that? Well, 314.27e tells you that you can have this application. It's called a compatible attachment fitting. We also have a definition, Article 100, that even talks a little bit more about these things. Now, they're not overly prevalent right now. You get them through Safety Quick Lighting and Fan Corporation. This is unique to them. But again, more and more companies out there will probably start using this design. But check them out. And they are okay. They are listed in the National Electrical Code to be acceptable for that. Now, here's an example of how we would typically run the circuit for a fan light unit. Again, I'm not going to get into circuit wiring for everybody, but it is residential. So this would be an example where we had a 4-wire cable, and we have a neutral, and of course we had, now this is full wire cable, but also what's not shown here is the equipment ground. So assuming the equipment ground is run. So you've got, this case is a black, red, blue, and white with an equipment ground. Okay. And so this case, you have the ability to control the fan. You have the ability to control the light. And we brought the power down here to the box. And then it's going through the switches. And this one's a rheostatic switch. And then, of course, you have the other one coming up. So then they come back up. Okay. So the neutral's here. We carried the neutral down to the switch box as well. And this is just one way of doing it when we're bringing in the source at the switch, at the actual fan box as well. This is an example of how we would do it if we're bringing it into the switch box. Again, you bring in the switch box. Again, equipment grounds run, not depicted here, but you know you have to have an equipment ground conductor 250, 122, sized based on the overcurrent protected device. But of course, when you're dealing with non-metallic sheath cable, the equipment ground for 14, 12, and 10 is going to be the same size as the circuit conductors. Okay. So anyway, here's how you would do it. You'd have a black, this would be like a 14.3. Okay. This would be example like a 14.4. So this is a 14.3 with ground. So you got the red, the black, and the white, and that's how you would run that switch. Okay. And this is what it might look like on the wall. And you've got other types of sliders and dimmers and all these type of things that you can work with. These are some neat ones where you actually have a little slider on the side, controls the speed of the fans and all that type of stuff. All that stuff is integrated in it. Now, we're not going to go into anything else in detail than those. Just remember that, again, that's basically what you've got when it comes to the bedroom. So let's come back to me. And remember, bedrooms. Things to cover. Let's do a summary real quick. Branch circuits supplying the bedroom for the outlets and for the lighting outlets and for switch devices and receptacle devices that are located in the bedroom, AFCI protected. Okay, and you're protecting AFCI is based on the branch circuit. In this case, we put it back in the panel. I think it was A19 was the circuit. The receptacle spacing, again, every 6 and 12 feet. So 6 feet from openings. And then you can go up to 12 feet so that no point along the wall line, no matter where you touched, can be more than 6 feet from a receptacle. That's if you put a lamp there. You got to make sure that 6-foot cord can reach. Again, any wall space that is 2 foot or greater requires a receptacle. If it's less than that, it doesn't require it. Always can put one, but it's not a requirement. On a sliding glass door on the exterior wall, the fixed portion is counted as wall space. So you start your measurement from the point where that fixed glass is and measure it and put a receptacle within 6 feet. But the sliding portion, you don't count. That's like a break in the wall line, just like you would for a normal door opening. Pretty simple. You can switch the receptacles in the master bedroom in lieu of a lighting outlet, or you can put a lighting outlet and switch the receptacles. The choice is yours, but you have to switch either a receptacle or a lighting outlet in that room. Ceiling fans are not required by code, but again, if you put them in there, we showed you ways to wire them. If you do put ceiling fans in there, and then they've got to have a certain box that's designed to support it, okay? If you have a ceiling box in there that you could plausibly install a ceiling fan, even if you didn't put it, you put a regular luminaire up, guess what? You got to think about the future. So you're going to have to put in a ceiling box that can support a suspended ceiling paddle fan, okay? And unless it's not plausible to install a ceiling fan there, means if it's a box over next to the wall where the blades would hit the wall, and it just makes it not practical to do so. What else in the bedrooms? Pretty much it. Switch heights, up to you. People ask me what my recommendation for switch heights are, and I just throw this out there. I tell people, usually I put my switch out at 50 inches to the box, to the top of the box. Some people put it to the center, some people to the bottom. I put all my receptacles, believe it or not, 18 inches to the top. I do everything to the top. Just my rule, do whatever you want. Sometimes you have what's called ADA requirements in some multifamily dwelling units, and they're going to limit you the heights that you can put. So that's ADA rules. Again, in the informative annex, you have some information about the ADA. But that's a local jurisdictional thing that they will give you guidance on, not an NEC thing, if you will. pretty much it. The receptacles outside, like in our diagram, can that receptacle outside be on the same bedroom branch circuit? Absolutely. Does that receptacle have to be GFCI protected? Absolutely. But can it be on with the branch circuit for the bedroom? Sure. It's not a problem. Not a problem at all. So just kind of all the little things that have to do with the bedroom. We talked about the lighting. We talked about some examples of how you'd run your circuits, receptacle spacing, all those type of things. So we covered a lot in this unit. It's a little, almost an hour and a half. So hopefully you got something out of that. You learned a little bit. Again, we only scratched the surface. If you want to learn more about residential wiring, go over to electricalinstructor.com, get our residential wiring course. There are so many units, so many tests, simulators. You will learn to be the best residential electrician you can be by going through our program, and you get to put that work to practice every day out in the field. Okay? So we're here to make you better because we build leaders. Till next time, stay safe. God bless.